All right, let's cover inverse trigonometric functions. So let's consider the three basic trig functions that you should know: sine of theta, cosine of theta, and tangent of theta. So those are the basic three trigonometric functions. Now, the basic trigonometric functions, they take an angle measurement, so theta, as an input value. So what I'm saying is you are inserting an angle into these. Where that theta is, you insert an angle. If you're familiar with working with degrees, you'd say 30 degrees, 20 degrees, 40 degrees, 210 degrees, whatever the case may be, or even radians if you're using radians. So pi over 2, pi over 6. You can even insert negative angles, for example, minus pi over 12. So the key is that you are inserting an angle as an input into these trigonometric functions. And what's the output? The output is a real number. And more specifically, so your output could be 1, it could be -1, minus 0.5, 0.5. In the case of tangent, you could get like 20, -20, whatever the case may be. Okay, we are familiar with that output. That real number output, it's the ratio. Okay, it's the ratio of sides of a triangle in a right angle triangle. For example, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, that real number is the ratio of those sides simplified. So that's just a brief refresher on what the trig functions actually do. They take an angle and they return a real number as an output. Let's look at the inverse trigonometric functions. So inverse trigonometric functions, since they are inverses, they do the opposite because they're inverse functions. Inverse trigonometric functions receive a real number as an input, and they are going to return an angle, theta, as an output. And if you've done high school mathematics or you did math in school, most likely there's a very, very high probability that you've been working with inverse trigonometric functions and you maybe haven't noticed it. You know, when you press sine and it has that -1 symbol, that's inverse sine. Cosine, -1 symbol in the superscript, and tangent, -1 symbol in the superscript. Those are inverse trigonometric functions. And think about when you use these. You used these to get an angle that you wanted to solve, whether it was a reference angle, whether you're working out an angle in a triangle and you were allowed to use a calculator. Okay, so these returned angles, you've been using them, okay, for a long time. You just maybe haven't been aware of them. Those are inverse trigonometric functions. So now we're going to formally define them and see how they work. So let's take a look at the first one. There's three, obviously, because there's three basic trig functions. So notice here I have y is equal to sine theta. Now, just a note, theta in this case is an angle. I'm using theta. I could use x. I'm using theta because I want to show you that we are inserting angles into the trigonometric functions. You can use x. I'm just trying to make it easier for you. So theta. And this y is the real number output. So y is equal to sine of theta. The inverse is theta is equal to inverse sine of y. How is this read? It's read as arc sine. Okay, so you can represent the inverse of sine with sine and then a -1 symbol in its superscript, or you can write it as arc sine. That means inverse of sine. Just something I want you to note. When you see this in the context of inverse functions, this is inverse sine or arc sine. I'm going to use arc sine a lot. It is not 1 over sine. This does not become a reciprocal. This exponent of -1, it is just notation to mean inverse. Just as when you had f and then f inverse. It does not mean 1 over f. Here your function is sine. It does not mean 1 over really why I like to use arc sine most of the time with a lot of new students, because then they don't confuse it with the reciprocal function 1 over sine. Okay, so that's the inverse of sine. The inverse of cosine, so y is equal to cosine theta. You have theta is equal to inverse cosine of y or arc cosine of y. Okay, pretty simple. And then we have the inverse of y is equal to tangent of theta. That is theta is equal to inverse tangent of y, or you can say arctangent of y. Okay, so that's how it's defined. Those are what the inverse functions are called. Now, You may be asking yourself, the trigonometric functions are not one-to-one since they fail the horizontal line test. What am I talking about here? Remember when we were doing inverse functions? Okay, I said only one-to-one functions can have inverses. So what I've just drawn here will have valid inverse. Take the parabola, for example. If I draw it's not one-to-one. How do I know that? If I draw a horizontal line test, do the horizontal line test here, it's going to cut the graph twice where I've just drawn. So it's clearly not one-to-one, and it clearly won't have a valid inverse function. So let's take a look at the trigonometric functions. Let's take a look at sine. Okay, so sine looks like that. And then on the negative axis, so that's my best drawing of sine right now. If I had to draw a horizontal line, it's going to cut it once, twice, 3 times, 4 times, and so on. Definitely more than once. So sine is not a one-to-one function. How is it that we now inverse sine or arc sine? Same thing happens with cosine. Okay, cosine is like that and like that. Again, not one-to-one. It fails the horizontal line test. It won't have a valid inverse. Same with tangent. So let's get this out of the way. Tangent, pretty clear to see. So it looks like that. And then there's an asymptote here. And then it looks like that. And there's an asymptote here. Okay. So that's tangent. Clearly, it is not one-to-one. It fails the horizontal line test. So how does it have a valid inverse? Okay. How is it that inverse trigonometric functions exist? So that's a good question. And the answer to that question is we must restrict the domain of the original trigonometric functions to make them one-to-one functions. So we are going to restrict sine, we are going to restrict cosine, and we are going to restrict tangent such that we can make them one-to-one functions within those restrictions. And I am going to show you what these restrictions look like on a diagram. For now, what I want to show you is this table. This table is, so I'm going to ask you to memorize that one, and then you can derive this table at the bottom. They're basically the same thing. I'll show you the changes. So I want you to memorize this one, and then whenever you need it, you can derive this one at the bottom. Don't memorize both. That's just unnecessary work. I am going to show you what the restrictions look like on a diagram in the next slide. But for now, let's just learn this table. Let me explain what we have to do. So what you're going to do is, and I want you to write it in this order, sine, cosine, tangent. Think of SOHCAHTOA, or how you remember the trigonometric angles. Sine was first, then cosine, and then tangent in that order of memorization. So sine, cosine, and tangent. Those are going to be your original functions. Then what we're going to do is we're going to write down the range in the next column and the domain in the second column. Normally, you'd be thinking, shouldn't I have the domain first because it's my input value, and then my range second because it's dealing with my output values? You can have it like that. I've just arranged it like this so that when you go to the inverse functions, you don't have to really draw another table. You can just erase some headings out and change it. But let me explain. So you're going to write the range down in the second column, and then you're going to write the domain. All you need to memorize for this first table is the order, and that's pretty easy. You already know SOHCAHTOA. Then you're just going to memorize these domains. So for sine, you have to memorize that as minus pi over 2 to positive pi over 2 and square brackets. Okay, square brackets. Then for cosine, you're going to memorize it from 0 to pi, and obviously it's going to have square brackets. And then tangent is super easy. It's just the first domain that you have now with round brackets. So that's all you are supposed to memorize in the first table. The order, and then minus pi over 2 to pi over 2, close square brackets, 0 to pi, square brackets, and then minus pi over 2, the first one basically, and we're going to have round brackets. Then, how do you get the range? So you don't need to memorize it. If you want to memorize it, it's fine. It's quicker. What I like to do is actually draw the diagrams out. So let's try and draw it. Let's get this out of the way. So we'll start with sine. So sine, okay, we are going from minus pi over 2 to pi over 2. So minus pi over 2 is here. And then let's try and draw it a bit better. There we go. So this is the sine function. When you restrict it from minus pi over 2, and then this will have a y value of -1, to pi over 2 here, and it will have a y value of +1. So those are your coordinates. Okay, so you're going from minus pi over 2 to pi over 2. You can clearly see that your range is from -1 to +1, and that's how I got that range. Let's look at the cosine function. So the cosine function looks like this. We are restricting it from 0. So here's x is equal to 0 to x is equal to pi. And we can clearly see that its range is from here to here. That has to be -1 to 1. So that's why I have this one. Let's take a look at tangent lastly. So tangent, it has an asymptote at pi over 2 or 90 degrees and minus pi over 2 or minus 90 degrees if you want to work with degrees. Notice that that's why we have round brackets, because at pi over 2 and at minus pi over 2, tangent is undefined. It has those asymptotes. So that's why we have round brackets and not square brackets like we did in the sine function. Okay, and then the tangent function looks like that. Why am I drawing it in blue? Okay, it looks like that. Again, you can clearly see that it's going from -infinity to +infinity, hence why we get that range. So that's how the first table works. Now, how do we go to inverse functions? So this is all you have to do for inverse functions. Write down arc in front of each one, and obviously change the heading to inverse function instead of original function. If you want, you can use the inverse notation where you have inverse sine, inverse cosine, where you have the superscript of -1. That's the first change you need to make. And then think about what happens when we get inverse functions. The domain of the original function becomes the range of the inverse function. And the range of the original function becomes the domain of the inverse function. So all you literally have to do is scratch that out, write domain, scratch this out, and write range. And that's how you go from table 1 to table 2. What I do is I memorize table 1, and then I just transform it into table 2 by making these changes I just said. If you want, you can memorize that one. It's perfectly fine. Okay, I just like doing this one because I can draw those graphs and see and check that I'm correct. So this is what you can use. This is the domain of the arcsine function, domain of the arccosine, domain of arctangent. And these are your possible output values or your possible angle output values, okay? Because remember, inverse functions, they return an angle as an output. Okay, so that's, I hope that table helps you.